So what are the advantages of Docker? So some crucial practical questions arise. Why would you use Docker and for what? The short answer to the why is that it gives a modicum of effort. Docker can save your business a lot of money quickly. Some of these ways, and by no means all are discussed in this slide. So we will see some of the most important advantages that gonna save a lot of money to your business. So the first one is it replaces virtual machines, VMs. Docker can be used to replace VMs in many situations. If you only care about the application, not the operating system, Docker can replace the VM, a virtual machine, and you can leave worrying about the OS to someone else. Not only is a Docker quicker than VM to spin up, it's more lightweight to move around, and due to its layered file system, it's much easier and quicker to share changes with others. It's also firmly rooted in the command line and is eminently scriptable. And the second advantage is prototyping software. If you want to quickly experiment with software without either disrupting your existing setup or going through the hassle of provisioning a VM, a virtual machine, Docker can give you a sandbox environment in milliseconds. The liberating effect of this is too difficult to grasp until you experience it for yourself. And the third benefit is packaging software. Because a Docker image has effectively no dependencies for a Linux user, it's a great way to package software. You can build your image and be sure that it can run on any modern Linux machine. Think as if Java without the need for a Java virtual machine, a JVM. Then the fourth benefit is enabling a microservices architecture. Docker facilitates the decomposition of complex system to a series of composable parts, which will allow you to reason about your services in a more discrete way. So this this can allow you to restructure your software to make its parts more manageable and pluggable without affecting the whole application. Then fifth, modeling networks. So because you can spin up hundreds, even thousands or lakhs of isolated containers on one machine, modeling a network is a breeze. This can be a great for testing real world scenarios without breaking the bank. And enabling full stack productivity when offline, because you can bundle all the parts of your system into Docker containers. You can orchestrate these to run on your laptop and work on the move even when offline. And seven, reducing debugging overhead. So complex negotiations between different teams about software delivered is commonplace within the industry. I have personally experienced countless discussions about broken libraries, problematic dependencies, updates applied wrongly. It's like, or in the wrong order, or even not performed at all. So, unproducible bugs, and so on, so forth, so on, so forth. It goes on. It's likely you also have done that. You also have experienced this in your career. So, Docker allows you to state clearly the steps for debugging a problem on a system with known properties, making bug and environment reproduction a much simpler affair and one normally separated from the host environment provided. And the eighth benefit that we have here is documents, software dependencies, and touch points. By building your images in a structured way, ready to be moved to different environments, Docker forces you to document your software dependencies explicitly from a base starting point. Even if you decide not to use even if you decide not to use Docker everywhere, this need to document can help you install your software in other places as quick as possible. Then the ninth, the last but not least advantage of Docker, enabling continuous delivery. Prestigious uh, advantage of Docker. That's continuous delivery is a paradigm of software delivery based on a pipeline that rebuilds the system on every change and then delivers to production or live server through an automated or partly automated process. Because you can control the build environment state more exactly, Docker builds are more reproducible and replicable than traditional software building methods. So this makes implementing CD much easier, damn easier if you want to say. So I will show you in our mega project module. We are gonna do continuous integration and continuous delivery and continuous deployment pipeline with Docker concept. Basically containers. Based on the containers will be built with the every change of state, and it will be after the integration it will be delivered to the ECR, a container registry. We will do that. We will do that in a mega project. So that's why brace yourself for the more action, guys. Because so Docker builds a more reproducible and replicable uh, than traditional software building methods. So this makes implementing CD much easier. So standard continuous delivery techniques such as blue green deployment, uh, where blue green deployment is nothing but where live and last deployments are maintained on live. Okay. And phoenix deployment is nothing but where whole systems are built on each release. That's called phoenix deployment, are made trivial by implementing a reproducible Docker centric build process.